Welcome and thank you for tuning in. You're listening to the Beyond 50 radio program. I'm Daniel Davis. Joining us back here on the program today is author Mark Kingston Levin. We're going to be talking about the third in his sci-fi trilogy, 30th Century Revived. But what's more fascinating than the stories is the science that he actually puts into his books so that we can come to understand things that seem to be very cutting edge. I mean, after all, we're talking with someone who received a B.S. in chemistry from the University of Vermont and who was also employed by Boeing on Project Apollo and later worked on the Mars project. He also decided to return to school to study under Nobel laureate Paul Dirac in quantum mechanics at the University of Miami, and he also purchased and was able to live on a yacht during his PhD studies where he was discovering blue holes and discovered deep caverns with stalagmites and stalactites. So this is somebody who was actually not only deep into the ocean but into space as well. I'd like to welcome to the Beyond 50 radio program today our guest and author joining us here on the Beyond 50 radio program today, Mark Kingston Levin. Mark, thank you for being back here on the program today.
Yes, thank you. I'm very happy to be here.
Oh,
thanks
very exciting stuff. Always an exciting conversation, too. We've had a guest actually email us who have been listening in, and they say, where did you find this guy here, man? This is more even cutting edge sometimes than some of the Star Treks that we've been seeing. Fun stuff. Now, first of all, let's talk about what 30th Century is, the sci-fi trilogy that you wrote, and we're talking also about the third in the series here and kind of give listeners an idea of what they're in for.
Well, in the beginning, there is a conflict on Earth because Jennifer, the hero, she starts out as Jennifer Levy because in her day, she is in North America. In North America, in the 30th century, the child takes a woman's name. And her maternal family is Levy, and so she has that name. And she leads a team of what's called the Secret Society of Scientists. It's a nonviolent organization, not designed well for combating what she discovers is that the Syndos, which were made in the 27th century, enhanced humans by embryo engineering to withstand the rigors of long-term space travel, like 150 years. By the way, in the 30th century, people lived for 800 years average lifespan. That's 10 times what it is today. And it's very possible that through this technology, we will learn to live much, much longer than we do today. The exact number, of course, is just my vision of what I see of the future. I think by the 30th century, we'll have that type of lifespan. So let's get back to Jennifer. So she is a young girl and is recruited in college into this organization. Well, partly with the help of her grandfather, who is sympathetic to this organization and was once a major member. The organization tends to be located in Hobart, Tasmania, and she migrated with her parents from French Canada to Tasmania, and always felt a little uncomfortable because she never got the Australian accent. So she has a little bit of a Canadian accent, and her main language is French. She's a French Canadian who immigrated to Tasmania and felt a little out of place because she didn't speak like the other girls in English. And she had to go to college in English. And, she had this professor, Sexton Ho, who was a Nobel laureate and is also working on this time machine, who recruits her into this secret organization. But anyway, she finds the Syndos are planning to sterilize humans with a new chemical they have developed, and are setting up manufacturing to essentially put it in all the water sources in the world, which, gives her some ideas. Her father has developed a virus, her grandfather is Raymond Levy, and he developed a virus which will correct the Syndos' defective DNA And it won't do it today because they have upgraded their immune system to the extent it kills the virus. So they have to go back to when they were children in the 27th century. And Sexton Ho has invented the time machine, but it's not completed the engineering of it. And his team is working on it. And somehow the Sindos find out he is not just a professor and not just a Nobel laureate, but also head of this organization, which they're kind of afraid of because they don't understand, because it's basically a nonviolent organization. They don't kill people. They don't carry guns. They try to find out information and try to combat things through things like boycotts. And they lead the humans into boycotting many of the Sindo businesses, causing conflict. In the end, her grandfather gets her into this organization. Sexton Ho is the leader. She kind of falls for him. He is an amazing guy, brilliant, handsome, and very strong mentally. But he gets assassinated, and from there, she kind of loses a little bit of her incentive, her motivation. But she leads the team back to the 27th century while under attack by the Sindos, and she planned then for them to attack her and seal her into a mountain, underwater mountain. It's an atoll in the Pacific where the French did their nuclear testing. She plans to cover it up with a large nuclear weapon and destroy everything that's in there after they trans-time out. So they will think that they are all dead, and they will be able to complete their mission. The biggest worry is that the Sindos find out about it, come back in time, and change it. So they keep it a secret. They keep time travel a secret. It becomes a very big secret. And Jennifer, in the later time of her life, is rescued on the Morro Island, where she trans-times to. Her team trans-times to the 27th century, and they carry out the mission. But she trans-times to 2015. She's a historian, and for some reason she's obsessed with this time, and she just feels, for a personal reason, she has to go there and see what it's like, to see whether all her studies and writings, and she's also an archaeologist, which is common among modern historians, and studies at this time. So she goes back there and saw exactly what she thought they were. When she gets there, there's nobody there, of course, because the French have abandoned that island. There are trees growing in the runway. I went there one time with my sailboat from Hawaii. It's about 2,000 miles due south. It's an amazing place, but I think that the Polynesian atolls there are about the size of Western Europe. It's a group of atolls. And then, of course, there's the high islands, the Tahitian islands. Mororoa is a very small island, just an atoll, just barely, maybe 10 feet above the ocean. A good storm washes over the whole thing. But anyway, she gets rescued there by Marty Vatusik and his group of graduate students. He has 4 graduate students, and there's a couple of crew members. And they fly in to do their various work, and they find her there. And she's in pretty good shape. So they keep her with them for 10 days until they head on their way back to Tahiti, where they drop her off, where she's mistakenly identified as this long lost. She pretends she has amnesia. That's the only way she can, avoid all these kind of questions. So she does a good job of feigning amnesia, and somebody recognizes her as a daughter of an heiress that disappeared some time ago with their family. They all disappeared. And so she's identified and by this banker named Julian, or Jules for short. And Jules becomes her guardian, legal guardian, and they become fairly close. Jules has a family, and he has a daughter that's kind of close to the age of Jennifer, but she's identified as Jennifer Heroes. which pronounced Arrow. It's French, Arrow, Jennifer Arrow. And she goes through the strain of adapting and investigating her background. They take her to where her home is in the Marquesas, which is being rented out by Jules and his family, who are managing the estate of her mother, who was also wealthy, as well as her father, who has a business with his brothers in Montreal, real estate business, and they are pretty wealthy. It's worth about $4 billion, I think, estimated stock value at the time. Her mother's wealth is worth about $250 million. So it's quite enough to have a separate sort of what you call investment for portfolio for her family. So they mistaken her, and more people identify her as the former Jennifer Heroes, who went by the name Jenny. Anyway, this leads to lots of conflict and very interesting situations, and Jennifer has to battle through a lot, including depression later in her life, when her supposed cousin from Montreal is a just graduated young doctor, and takes her DNA and identifies her that her DNA is the same as her relative's DNA from an old hair sample on a brush. And this causes her to go into depression. And because she thinks her memories of growing up in the Laurentian area of Montreal, in this beautiful countryside in the 20th century, and being a part of a secret organization and all of this, was an illusion. She thinks a delusion. She thinks she's going crazy, and because how can she be two people in different time periods? Maybe there's no time travel. Maybe she really does have amnesia. Maybe she just has a delusion, and that drives her into depression. And how she gets out and carries out her mission is, of course, for the readers to find in the book. But there's a lot of science in it, and particularly recently, we just found something that Jennifer had kind of been working on. She also works in physics because she wants to understand more about her former lover, Sexton Ho, and how he was able to invent the time machine and do so many other great things that he did, and lead this organization, a nonviolent organization. And she has to help herself to a lot of things that she's having trouble adjusting to. So she goes through what you would call some of the emotional, psychological events of just not being able to handle it. But one day, she had been in Nukuhiva, which is the Marquesas Island. She had met a girl, and this girl was her playmate when she was a child of this Jennifer Heroes, and she recognizes her as Jennifer Heroes, and but Jennifer doesn't recognize her back. But after a while, they talk, and they find out that her mother had an obligation to provide educational funds. So she calls Jules. Jules finds it, and it is a scholarship fund for this girl who wants to become a doctor and practice in Nukuhiva. So she takes her and her mother to Hawaii so they can go to get into the med program at the University of Hawaii. In the meantime, Jennifer's real sister, not known to her that they were broken up at childhood, or really before childhood in the embryo stage, and was given to Jennifer's twin, was given to her real biological mother and father, and that Jennifer was actually with an adopted family, but was her uncle. So it's a little complicated there, but all in all, she comes out of her depression and leads the team to return to the 30th century with a victory and the saving of humanity. And for that, she's granted some privileges, and she needs to go back to her husband. She gets married, and in the 21st century, to that Professor Marty who saved her. And he has 5 stepchildren. I mean, he has 5 children. She has 5 stepchildren. And later, she gets pregnant and has twins. So this is kind of the story of how she adapts in the later books to motherhood. And to her, she became one thing I didn't tell you, but in her young college age, when she first got onto the being a secret agent, her first mission was to go into deep cover with this senator from Tasmania, and then later from New Wales. But the senator's name is Caps Grotto. Senator Caps Grotto is a key player. She saves his life when she's a young girl, about 18 years old, 19 years old. Excuse me, I just need a little drink of water. And after that, she becomes the hero of Australia, June Levy. And the Sindos take her as a hero because this fellow, Caps Grotto, is a Sindo. And he's a Sindo whose politics kind of favor equality. He's different than most of the Sindos because his genes have evolved, and he no longer has this defect. And she discovers that by taking his DNA. And now they just don't understand how. The virus, they exposed Sindos to it and rejected it, but his DNA is actually changed, and it's corrected itself. So this gives them some encouragement that the new virus will work, and in the 27th century, when they're young children, 6 or 7 years old, and the story of how they do that, how they go back. And then in book 3, we deal with neutron stars. We recently had a neutron star collision, the first one ever observed by gravity waves and telescopes at the same time. We learned from this event that 100 times the mass of the Earth was made in gold, and 5 times that of platinum. 500 times the mass of the Earth was made in platinum. So Jennifer had kind of predicted that in her models. She's studying physics and archaeology, and in the 30th century, people don't get 1 PhD; they get 3 or 5 PhDs, and this is because they have such a long lifespan, and it becomes common for scientists, avid scientists like Sexton Ho, has 5 PhDs. Mostly physics, chemistry, and mathematics, he also had other things that he loved, like history, and he focused mostly on most of his life on physics, because that's where he was most successful when he was in his youth, and it was also the most challenging for him. So it was, he's kind of like a hero, but he dies. And in the 30th century, the last book is called 30th Century Contact, and their way to solve the problem of the collision. They know in the 57th century there's going to be a collision. Well, a collision probably going to be before that, but it's going to hit the beam. When you collide 2 neutron stars, you form what's called a gamma ray burst. Very intense. It lasts for a short time, but in that short time, it produces more light, more photon energy than a galaxy does in a year. And this beam comes out 180 degrees apart, and if it hits you as a planet, it blows your atmosphere away and it kills you. And they know it's going to hit in the 57th century. So they go to the 56th century, and they get help from the people of the 56th century, and they have the technology, and they take an asteroid and they send it out to collide with one of these stars. Just before it collides together, it will move the beam just enough to miss Earth and Mars, which are aligned at this time, and it will wipe out the life of both of them because Mars has been terraformed and people are living there in an atmosphere of oxygen and carbon dioxide. It's been completely terraformed in the 25th century. So this is a history of one of the girls who was the deputy commander in this organization, and her name, her name's probably not that important, but she is the deputy commander who has been an astronaut and has been to Mars, and there was a disaster on Mars, and they led a rescue to save Colony 6 from a hit on an asteroid and hit nearby. It was a very small one, but it was able to crack their facility and damage their facility, and they needed help, and she led a team there. But that was Jennifer's deputy in command, and she's important in book 3. But in that book, the aliens are brought back. This artificial intelligence that was sent as part of the asteroid, which was made into kind of a small city for humans during the time they built the asteroid, to be a kinetic energy impact to save Earth in the 57th century from this fate. They were able to send him out, and the thing that happened is that he reproduced himself, had a child, and that child comes back to the 30th century looking for Jennifer. The people, or a very large portion of the world government, would say there were two factions. One of those factions, led by China and India, which is the majority of the world's population at that time, and they want to attack this because they think it's the same one they sent out to do its job. It came back. They think it's not doing its job, and so they do attack. And the story of what happens after that, I think we'll keep, for the reader to discover.
Absolutely.
But that's kind of, what it's all about, is a neutron-star collision.
Well, now let's talk about the science there. It's really fascinating because of your depth of knowledge in this area, and you were just talking about a collision that was just recently observed. But let's talk about what neutron stars are in the first place. Okay.
Well, when a certain mass, say 3 times the Earth to 10 times the mass of the Earth, it goes through a supernova, they form neutron stars. A very dense material, but not quite a black hole. If it gets any larger than 10 times the mass of the Earth, it forms a black hole. So when 2 neutron stars collide, it also forms a black hole. But the thing that we didn't know that the gold, platinum, uranium, all the heavy elements, silver, copper, all the heavy elements are heavier than iron. How they're made? We just learned in October 2017, it was announced that this collision was observed both by gravity waves detectors. We have 2, one in Hanford and one in Livingston, Louisiana, and these are for real. And they did detect this collision. And that book was written before that happened. the story was written. Of course, I have to edit it and get it out and get the artwork and all of that. Book 2, by the way, is just coming out this month. It will be out in a couple of weeks. And that will be, wonderful to see. And then maybe in June, the third book will be out. It's a matter of getting, proofread and edited. And I think it's been edited, but I think it needs proofreading and then what you call this formatting, or some people call it book design. But it's just the interior of how the chapters lay out and how it's formatted and how the illustrations get into the book and where they get placed, that type of thing. It does take time. I mean, you have to get the illustrations right with the proper. I'm doing them in color now, and that's a little bit more difficult. If you do in black and white print, it's much easier and cheaper. But I'm doing them in color because I think my readers deserve the best, and so that's why it takes a little bit longer. I'm using a different publisher. I'm using Ingram Sparks, and they do a pretty nice job on color. So they're one of the biggest design on, what they call it, produce on demand. Right. They can produce 1 or 2 or 10 orders at a time, or 100 or 1,000.
Okay. And so what I wanted to get back to was the question on the neutron stars, not necessarily publishing a book. Sorry about that.
Right. Okay. Let's talk about neutron stars. First of all, if they are big, if they're too small, they will form just another big neutron star. But if they are the right size, they'll form a black hole. And in the process, they give up tremendous amount of energy in the form of gravity waves. And by the way, one thing interesting about gravity waves is distorting space-time. And people realize by this being able to distort space-time, with this, you have the power of time travel. There are wormholes out there, and we haven't talked much about wormholes, but those are things that were predicted by Einstein 100 years ago. And we've recently, found gravity waves through Einstein's production, and we haven't found wormholes yet. We've been looking, and maybe it'll be another 100 years before we find them, but eventually we'll find them. And by modifying what we really call these wormholes, like a wormhole, or recreating them in a very small space, we can go either forward or backward in time. And of course, in the very beginning, when Jennifer goes back in time, there's only a one-way time machine. I didn't explain that, but it's really very important. They didn't have the technology until the 32nd century about two-way time travel. So in the beginning, her mission is a one-way mission. So she doesn't think she's ever coming back. So she thought she's going to be stuck there. But later, her sister, we talked about her twin sister, she learned she has a twin sister when she calls, and that's what really gets her out of depression, because now she has a reality again. She realizes that her twin sister was the reason she was being misidentified, and that this all made sense because they were part of an experiment, and the experiment was to find out how twins will behave if they are growing up in different times and different centuries. It's a little bizarre that parents would do such an experiment, but these guys were, let's say, very curious about this, because when they were twin brothers, okay, and, twins run in families sometimes. Like my father was a twin, my grandmother was a twin, but I didn't have any twins. I had 4 kids, no twins. But my sister had twins, and so it tends to run in families. So, it's a little bit more interesting for me because of those reasons. Unfortunately, I don't know everything. So I'm still learning all these things that are being confirmed. When I wrote the book and wrote about these chapters, it was still science fiction, and there was no proof of neutron star collisions producing these heavy elements. And we still didn't know for sure in many scientists, in fact, the majority of scientists, thought they would be formed in supernovas, and that's not the case. Maybe a few percent in the supernova, but probably 90% or more of there may be quark stars out there too. We don't know. That would be an intermediate dense phase, but nobody's ever found them. But people have been looking. But some scientists predict them. But right now we have neutron stars, and that's pretty solid evidence now from gravity waves, and we're going to discover so much more. That gravity waves are probably as big a discovery as was made by Galileo when he pointed his telescope to Jupiter and found that they had moons. And that was a very great discovery about astronomy. But we're going to have a new branch of astronomy, which is going to be called observing gravity waves. We have these observatories, and now the Europeans have them, and others have them, and I'm sure the Russians have them also, but I don't know it for a fact, but I'm pretty sure they have the technology. They are very, very strong in astronomy and always have been. So I would think that they would be developing this technology if they haven't got it developed. But my best guess is they haven't. Yesterday they claimed to have nuclear weapons that can get around our defenses, similar to cruise missiles. And they kind of scared the world a little bit because we really don't think of the Russians as being a Cold War advocate right now. And this puts them back in that kind of phase where they might have missiles aimed at us right now. We don't know for sure that they do. It may be just a political ploy by the current head of Russia who wants to get reelected. So, but he did make a strong statement about his nuclear weapons. But let me get back to neutron stars and to the artificial intelligence who brings back Xenians, which is a species very similar to ours, with a similar IQ and a very different history and history of evolution. That story I don't want to spoil for you, but it is the kind of the ending, and it really deals with artificial intelligence, not as the bad guys like in Terminator, but the good guys. And I think that's important. I think that's part of my vision of the future, that artificial intelligence will enhance quality of life for man and any other humanoid species out there, certainly by contact and exchange of information. But there's a very big danger that there's some sort of biological incompatibility that could arise, and diseases could spread. And this is something that we have to contemplate when we visit. We have to isolate ourselves from any new contact for a period of time, and that could be a year or more, and to make sure that we study this in very great detail. But anyway, that's a danger that we have today. I mean, when we come back from the moon, we go through isolation and sterilization for about, I think, just 24 days or something like that. Mars will do the same thing, but probably much longer, probably months. If we find any life there, it's probably going to be for years. So, I'm talking about life that might be under the surface, bacteria growing in very deep caves and things of that nature, like we have here on Earth. We found on Earth that can live off a rock and water dripping through the rocks. Mm-hmm. The bacteria eat the rock, and this can happen on Mars too. This form of life. Would it be compatible or would it be incompatible? We don't know.
Right.
So, but that's a big issue in the future. Artificial intelligence can really help us, and we need to move, in that direction. I personally see the future as a very positive thing. Great cities, 2-mile-high buildings, and tremendous transportation systems traveling through vacuum tubes. that will stretch all the way from the Alaska to Hong Kong direct, much faster than through the air. Even though by that time we'll travel 1,200 miles an hour through the air, we will, commonly cruise through these things at 3,000 miles an hour through these vacuum tubes. So it's still going to be faster to go by train. And this may surprise people, but that's the way I see the future. And this trilogy is really a vision of my view of the future. And the view is there's some strong characters. Many of my characters are women. My two leading characters, I'd say, are women. Certainly Zexon Ho is a leading character, but he gets assassinated. And later Marty becomes the romantic interest of Jennifer. So the physics of neutron star, it's the densest material known to man. And if you took a teaspoon of it, it would weigh as much as Mount Everest. So it is very, very dense material. Tons, a teaspoon would be billions of tons. And that, would be, the gravity would be so great that if you held it in a spoon, it would go right through the spoon into the earth and make its way to the center. We don't have any neutron star material here. Thank goodness, it would mess things up probably. But deep in space, it makes us rich with gold. And I think that's very important. And so it blows out and it seeps through the universe. Will it come here? Well, it's 130 million miles away. The latest collision, I don't think we're going to see that material. Because to travel at the speed of light, it would take it 130 million light years to get here. That's too far. But in its galaxy, it will spread out in that galaxy. It won't get here. But someday we'll have another neutron star collision in our galaxy. By the way, neutron star collisions frequency, based on what we know about the gamma ray burst, probably is 3 per million years per galaxy. So they're not a common thing. And if one happened in our galaxy, it would be threatening. Okay, if the beam hit us, even from 500 light years away, it could be significant. Our galaxy's width is probably about 100 million light years. So, half the distance, an average one might go off would threaten Earth if its beam was pointed in our direction. And it would mean no more atmosphere, no more surface life. Maybe in the deep trenches, some life would survive. But that's the kind of thing that we have to face. That's a new danger we didn't know about. And I think we're much more aware of it now. By the way, neutron stars are very hard to detect. They have what I call pulsars, and those come back from the day when I was studying astronomy. When I was at the University of Hawaii, they have a wonderful observatory in Mauna Kea. But the problem is you teach in the daytime, and then you have to fly over, get a car, go up to the top of the mountain, and then start looking at nighttime. And nobody can stay awake all night, but you have to be up there for 4 hours shift or something. And then somebody takes over, and you get kids to sleep. And then you have to fly back from 200 some odd miles away from Kona coast to Honolulu, and get back to your university and get to teaching your class. So it's a kind of strainful for a young kid. I got my PhD in 2.5 years, so I was not much older than a graduate student when I was teaching. And I find it very exciting. And expenses, of course, were all paid by my grants and those types of things. But it was a humbling experience to see the power of that telescope at the time. And they're still very powerful. But today, the telescopes that you're really interested in are the ones that are in outer space. They are phenomenal. Hubble has been phenomenal. It was named after Edwin Hubble, who discovered that we had galaxies. And those big stars that he thought when he got the big telescope on near JPL, what is it called, Mount Wilson. He had the best telescope in the world. He discovered that all those things are other galaxies, and that we're just one galaxy. And he characterized these galaxies. He studied them. He was an amazing guy. And therefore we named that after him. But James Webb Telescope is coming. It's going to launch next year, and it is going to give us at least seven times the power of the Hubble. It will be an amazing time of discovery for these great astronomers of today. We'll be able to get data like they've never had before, and they'll understand the universe much better. So I think that's going to be a wonderful telescope. We have gravity wave detectors, and we're going to upgrade them, make them more sensitive. We're going to be able to find many more types of collisions. Let me say that so far we found 5 different gravity wave detection systems as of last year in October 17th when the last announcement came out. Then they shut down the instrument to upgrade it and make it stronger. So hopefully that will be done and by the end of this year, and we'll be back listening. Some people call this, sound, the vibrational distortion, and of space-time itself. Understanding that, of course, Einstein did through theory of relativity. It's an amazing theory, but there's some things wrong with it because quantum mechanics tells us you can't be infinitely small. You can't be smaller than a Planck's length. There are only certain states of energy that you can have, like hydrogen has certain states, and the photons can be this state, that state, or that state. They can be between the first and second, or the third and the second. And that means that the electron has orbits, and those orbits can only be in certain energy states, and those tend to be the quantum numbers we call state 1, state 2, state 3, about the quantum numbers. And so hydrogen has lines. It only gives out certain types of radiation when you heat it up, and we see that from the sun and other stars. So this is, and there's a lot of nuclear chemistry that goes on in the formation of the gold and the platinum and silver and all those other elements like uranium, all the heavy elements. They're very valuable. In fact, humans couldn't live without them. We have things like molybdenum, selenium, and other things in our body that are very important in enzymes, and those use heavy metals, copper, and many of the other elements. They don't use gold, but gold becomes very important for other reasons. It's very good in electronics, silver also, and of course it's jewelry. The women love it. But platinum, I think, is the most valuable of all the heavy metals. Iridium and rhodium are very rare and may have a higher value number, but I'm talking in terms of industrial use. Platinum is a phenomenal catalyst. Palladium also. They're used in our catalytic mufflers to keep our air clean. So we're here on Earth today understanding how those metals got produced and how they got to Earth is through a massive explosion of 2 neutron stars that sent these shock waves out. Just to give you an idea of the energy in the shock waves that recently came, I'm calling them their gravity waves. They're not really shock waves, but they distort space-time. So in a way, they have such energy. If you took 5 Jupiters and converted them into energy, that would be the energy that was produced in that neutron star collision that we recently announced in October 2017. And it is one of the biggest discoveries of all time. So I think we're very lucky to have such exciting science taking place while I have these books which talk about this science and in some way predict some of the new science that will come out of it. And I think understanding what Einstein once called wormholes are very important for both quantum mechanics and relativity. And I see the combination of quantum mechanics and relativity We see it happening now, what we call string theory or superstring theory, M theory. This is what really happens in the theory of everything. I don't know if you heard about that movie, but the theory of everything was really all about what Einstein tried to do in his later years is combine all of the forces into one equation. He was not successful, and he passed away without doing it. But now many other scientists have tried to do it, and the group that's the leading is called the string theorists, and they started as string theory, but there's some superstring theory and other things, but those are just variations of this theory. But it's the theory of everything. It is the leading theory. There are many reasons why there are other theories, because there's nothing to test. One of the biggest problems with theories is it's philosophy if you can't test it.
Right.
It's not really a theory. You have to have a theory. You have to predict experiments that you can test. And string theory hasn't done that yet. I mean, I think maybe it will in time. I think that might be on the right track, but there's also other theories. And one of them is quantum loop theory. And that is really trying to combine theory of relativity with quantum mechanics. And it's focused. It's not the theory of everything, but it is making progress. And if we can overcome equations that go to infinity, because you can't go to infinity in reality because of the Planck's length and other things, there is nothing smaller than a Planck's length. And that's about 10 to the minus 35 centimeters. It's small, yeah. And it's much smaller than a proton or an electron. So, but we have those limits. And so what happens in those equations if you put those limits in? And you can see that from current theory. There are theories that are handling that in that way. And I think it leads to different things. I think Roger Penrose, a famous, now knighted by the Queen, theoretical physicist in Europe, has what's called conformal cosmology, CCC, conformal cyclic cosmology, where the universe reforms and has another big bang and keeps on continuing that kind of process. And I would say it's probably one of the second leading theories. Certainly, it has a small following compared to string theory, but it doesn't mean it's not right. So I think it's testable, and I think that's a big advantage over string theory. Maybe string theory in time will come around, but string theory is a much bigger job. It's a theory of everything. Doing the theory of everything is a much, much more difficult mathematical job than just trying to combine gravity with quantum mechanics, and we call that quantum gravity. So, those are the leading edges of where science is today. Hopefully we'll make progress in the next few years. We have such great tools from NASA and other countries, Europeans. In Italy, the Italian and French have a device for detecting gravity waves, and that has verified our detection. So I think it's very important that these technologies will be throughout the world, India, China, in 10 years. They will be able to just copy what we did. And the sensitivity of these types of devices are unbelievable. It's like 1 part in a million accuracy, and they will get better by improving the lasers. I can talk a little bit how this technology works, but it is fairly complex. But interferometers were built by one of the first great American Michelson-Morley experiment, and it was done at Case. It's now Case Western Reserve. but it was a case at University, it's in Cleveland, Ohio, 1880s. Okay, in the 1880s, he invented interferometer physics. An interferometer is where you send light out and you bring it back. We use lasers now, and it's greatly upgraded, like 4 miles, and we bring it back. We split it and we send it back, and we look for distortions. If the beam will cancel it out, if there are no distortions. If there are distortions, you'll see something, you'll signal, and that's how we detect gravity waves. And I want to give credit to those great men who, Michelson and Morley, who conducted that experiment. And those were the first great American scientists who, I think, won a Nobel Prize. So it's a long time ago. We have a lot of great scientists now who continue to win Nobel Prizes. And some of them are here in Southern California at JPL and Caltech and other great universities around. Certainly, there's been a great deal of work on genetic engineering. It's a little bit scary to a lot of people, like cloning and things like that. But it's continuing to be done, and we're continually cloning animals. In fact, I think it's even commercial now. You can clone your pet if you want. So this is something, there's not a really true clone because it's not just the genetics that counts. It is the experience that each individual, if you made a twin, you cloned yourself, be a different time, a different exposure, and you wouldn't be exactly the same. Even though your DNA might be identical, your mind would be different, and you'd be like a twin. Twins, they develop different attitudes, and some of them dye their hair differently. Some want to be blonde, some want to be redheads. But even though they don't look alike because they have different colored hairs, they are very much alike. And I can testify to that. My daughters, my sister's twins were identical twins. But they have, you have different types of twins. You have fraternal twins that are not quite the same. And different sperm, not the same one that divided. It's the way the eggs divide. For instance, it's caused by 2 sperms or 1 sperm. Yeah. And if it's 1 sperm and the eggs divide, then it's identical twin. Do you have any other questions about the
No,
book?
I think you've actually proven to our listeners that science fiction is getting further away from the fictional part and closer to the science part and accuracy as far as the development and the reality of the whole thing.
I try very much to stick to real science. Mm-hmm. It's all based on science that I know. So they call that hard science, but I try to make it very easy for my listeners to understand. I take out all the math equations. Of course, I had an editor. I probably put too much science in the beginning. They took the part where I wrote equations out, which, they understand what the market is, and most of the readers are not really interested in learning the math because math is a little bit detailed, using vectors and matrices. The mathematics let's put it this way, it's good for computers. Computers can solve these things very quickly today. Mm-hmm. So one way we do this is by computer simulation. We simulate the universe on the computer, and we make various runs, doing different things. When I worked with Dirac on cosmology in the early 80s, I wasn't really very good at doing it. But, as I kept thinking about it more and more, I got the idea of what he was talking about. He told me that he thought perhaps some constants that we thought were constant were changing. He says, question everything. You got to question everything. Maybe the gravitational constant is varying slightly over time. And he even predicted 10 to the minus 39 per year or something like that. And I think it was dealing in seconds, minus 39 seconds. would be a parameter of the kind of variation you would see in a gravitational constant. But today you can put this on a computer and simulate the whole universe and see with these variations how it would form and which would be correct. So I think today Dirac's theory may be testable. And I think very important to have theories that can be tested, at least by computer simulation.
Absolutely.
And I think that's coming. I think more and more our computers are getting better and better. And another 10 years, we'll be able to analyze a lot of this data that we're seeing in gravity wave collisions and then simulate them and learn more about through computer experiments. You can't control the universe, and you can't restart the universe and make it do this, make it do that, but you can do it on a computer. Right. And I think that's finding out where we are today and how it would evolve. What are the equations necessary to make it evolve? We have a lot of mysteries still, more mysteries than we have answers. So we're going to find a lot more out. For one thing, we don't really know how the universe expanded. I mean, the period called inflation, where if you follow this theory of inflation, which it's kind of necessary in string theory, I think, the universe expanded for a period of time faster than the speed of light. I know Einstein said that was impossible, but space may be able to travel faster than the speed of light. Space is something, and we have to really understand what space is. And Einstein was the first one to realize that space is not nothing. It can be distorted by gravity.
Right.
And he called it space-time. And for one reason, because he was working with relativity. And when you get very close to a black hole, it slowed down. Time is not the same. And you want to emphasize that depending on where you are, your clock will run differently. If you're in space, just above Earth, it's going to run slower than it does down here.
I know it's all pretty fascinating stuff when you think about things such as time and time travel and how time is different. And I mean, you take a look at, for instance, just on our own planet alone, how time is differentiated in different areas, from Eastern Time to Pacific Standard Time and the like. And it's pretty fascinating stuff. And I know people can find out more about your work. Where's a website they can go to find out more about all this if they want to become
30thcentury.org.
30thcentury.org?
Well, 30thcentury.org. That's my website. Yeah, It is kind of focused. It's a little bit like an author's website, set up like an author's website, but it is more on this particular trilogy, and it focuses on these three books that are in the 30th Century Trilogy. So 30th Century Escape was the first book, and it won an award for the best science fiction book of 2017. And I was very pleased to get that from the book publicists of Southern California.
Well, we want to thank you so much for being on the program and sharing this information with us. It's always a fascinating exploration into not only the stories that you've written itself, but also the science behind all this. And I think people find this very intriguing, and they can find out by going to 30thcentury.org is the website where you can find out more about this. Mark, I'd like to thank you for being on the program today. Unfortunately, we just ran out of time.
Well, thank you for having me.
We'll have the opportunity to have you again soon, hopefully.
Okay.
Thank you very much for being on the program today.
Yeah, and to all your listeners, have a nice day. Thank you, and goodbye.
You bet. We want to thank you, the listeners out there, for joining us. You can discover more at Beyond50Radio.com. That is the number 50. We do encourage you to sign up for our weekly e-newsletter and keep up to date with what's going on in the world of Beyond 50, as well as our upcoming shows. I'm Daniel Davis. Thank you for tuning in. This is the Beyond 50 Radio program. And remember, live your day past halfway.